Hello. So today we are going to be discussing an experiment which tests the conservation of momentum of an inelastic collision. Uh, this experiment involves an air track, two cars, a magnet, some clay, a needle, and two motion sensors. Now, in general, with inelastic collisions, momentum is conserved, but not kinetic energy. Now, kinetic energy isn't conserved because after both cars collide, their velocities become the same. Additionally, momentum is actually considered to be a vector when kinetic energy is just considered to be a scalar. Now, throughout the duration of the experiment, we will be ignoring drag or considering the force of drag on both of the cars to be zero. And in total, there are 10 trials in this experiment.
Now for this experiment, we needed a completely inelastic collision to determine whether or not momentum was completely conserved. And with the materials provided in the lab, we were able to design an experiment that met our criteria of having as little external forces acting on the carts as possible. And to make the experiment free of friction, which if present would cause momentum to be lost, we used our carts on an air track to remove the friction between the ground and cart that would otherwise be present. Now that we have established a frictionless track, we must make the force pushing the cart constant in order to get accurate and consistent results each and every time. We are able to achieve this by using the repulsion forces of two magnets, one attached to the rear of cart 1 and another near the beginning of the track. This ideally will give us a consistent push force on the cart for every trial. Now, as seen in the figure, we have two motion sensors, one on either side of the air track to measure the velocities of each cart before and after collision. And in order to make this completely inelastic, we have affixed a male needle and a female clay clump, which will hold the two carts together as one object after the collision. This is an example run as seen on Logger Pro. The important data points of the graphs are at the points where you see the slope of the position or the velocity change. This is where the two carts are coming into contact and begin moving as one.
So we know that in completely inelastic collisions that kinetic energy isn't conserved. But we can use the conservation of momentum theorem to see whether our data shows a loss in momentum. So ideally, delta P would be 0, but if it's some value close to 0, that may be due to some form of error we've already accounted for. So mass 1 is 216 grams, and mass 2 is 201.7 grams, and both of these remain constant. So this is the data we collected from Logger Pro. As trials 1 through 10, velocity 1 represents the velocity of the initially moving cart. Velocity 2 represents the velocity of both moving together after the collision. P initial represents the initial momentum of the moving cart, the initially moving cart. PF represents both of them moving together after, and delta P is the difference of the two. So after that, we calculated the mean on delta P, which was 2.37 newtons per second. And then we calculated the error on the mean of delta P, which was 0.927 newtons per second. And that gives us a deviation from 0 or a deviation from no change in momentum of 2.37 newtons per second with the given error.
For our discussion, we'll be going back to our initial question of will momentum be conserved? Ideally, it should be conserved. However, we can see that the momentum is not totally conserved in this completely inelastic collision. The difference in momentum P should have been 0, where our error is plus or minus 0.92 newtons per second. However, our real difference in momentum is 2.4 plus or minus 0.92 newtons per second, which goes against our initial assumptions that it would be totally conserved in this completely inelastic collision. We chalk this unconserved momentum to a number of errors in our experiment. We assumed that the drag force is 0 or negligible, and so we did not include that in our calculations. Another error could be in the magnets used to propel the car, where the air track interferes with the propulsion. These factors could have resulted in our uncertainty as well as the increase in momentum after the collision. We can improve on this experiment by setting it up with an air track that does not interfere with the magnet, as well as being in a vacuum environment to remove all drag and airflow that might interfere with cars. And thank you for listening to our report for the Conservation of Momentum Lab.